Okay, so it's Sunday evening, and Mr. Brigham is making potato, corn, and leek chowder right now. I thought while I was doing that, I would try to give you the solution to the first problem, so you had something to work over. So before we even begin on the problem, the whole key to these is keeping things separate. You have to remember that the vertical stuff will appear on the y-axis, and the horizontal stuff will appear on the x-axis. V is in blue, H is in red. They will not intermingle with each other. And remember that one thing on the vertical axis will be a location and appear in the equation. And one thing will be a set of directions. And the same thing in the horizontal. One will be a location and one will be a set of directions. So let's see what information we can find out. First thing I'm going to do is write down my, my acronym of sinusoids or hilly places. Sinusoids are hilly places, and then I'll add D this word in, and I know with horizontal dilation is related to the period. HD appears in the equation, period appears on the graph. So with the equation, we're just going to work from the top on down. The first two things are in the y direction, they always will be, and the second two things will be in the x direction. So we're looking for the sinusoidal axis, that orange line, and we're looking for the amplitude, the height off of that line. Now I have a small problem, not a major problem, and then I know from this line up I go to 2.56, and from this line down I go to 0.34, but I don't know what number that line is at. But remember, it's always, always, always chopped up evenly. It's always halfway in between. So I'll do 2.56 minus 0.34 to find the distance between the top and bottom, and that will be 6 minus 4 is 2, 5 minus 3 is 2, 2 minus nothing is 2, so the total distance from top to bottom is 2.22, so the distance from the top to the middle is going to be half of that, or 1.11. That tells me the distance, not where it is. It tells me how to get there. Now I got to get there from either the top or the bottom. So what do I do with that 1.11? I can do either thing. I can add it to the 0.34 and go up, or I can subtract it from the 2.56 and go down. Either way, I'm going to get the same answer, and that answer is going to be 1.45. 1.45. So the sinusoidal axis is 1.45. The amplitude is the distance from the middle to the top. I think I already found that. That's going to be 1.11. Good job. Okay, now we've got to find the two harder ones, the period and the phase displacement. The period is the distance for one complete cycle of the curve, which is, let's do it in gray, which is this distance right here. And darn it, I don't have the whole distance. But what I do have is the distance from here to here. That's half the distance. So how can we find how far that is? Well, from here to here is 16. And I know it's not to scale, so don't worry about it. 16 and 2 more. 16, 17, 18. So that distance is 18. That's half the curve. How much would the whole curve be? If that's half, we add it all together, and we get 36. So the period is 36 degrees. So whichever one of these I have, the horizontal dilation or the period, the other one is equal to 360 divided by that number, 36. I can leave it like that, or I can simplify it and make it 10. Whichever you do doesn't necessarily matter. Phase displacement, I have to decide whether I want a sine curve or a cosine curve. I'm going to take a sine curve because the sine starts on the sinusoidal axis and then goes up. Can I find a point that does that? This point does that. I don't have the value. The other one that does it is this point right here. And what is the phase displacement? The phase displacement is negative 16. I now have my four pieces. I'm going to put them in order into the equation. I'm going to write them down. Tell me if I did something wrong. Okay, so I've written this equation down. You think I did anything wrong? Let's take a peek. The first thing is the sinusoidal axis. The second thing is the amplitude. The third thing is basically the flip of this period, which is the 10. And the fourth thing should be the flip of the phase displacement. This is minus 16, and should be the opposite of minus 16. This should be plus 16, so it's going to be the opposite of what's there. Those 4 pieces are in there. There's another way you could write the problem down, which would be correct. It could also look like this. You could also write it like that, leaving, instead of simplifying the horizontal dilation, you could write it like this. I actually prefer it this way, because when you write the horizontal dilation that way, you can see the period, because it's on the bottom of the fraction. Okay, we're going to enter that in the calculator on Tuesday and see what we get, but this should be a guide for the other problems you have to work with. Give it a shot. Maybe another solution will pop up this weekend. Give it your best, and I will see you on Tuesday.